Here I'm reminding you how to use this template. Each one of these symbols is 1 gram of water. You use dilute hydrochloric acid. It's mostly water, so this is a reasonable way to visualize what's in this solution. Mostly water. We're making an approximation, which is mostly true, that 1 ml of acid equals 1 gram of H2O. Down here it reminds you of what the beads are for. The beads represent joules. There are the big beads that represent 40 joules. The small beads represent 4. So here's a big bead and a small bead. That's 44 joules total. And each big bead raises the temperature of that gram of water by 10 degrees C, each small bead by 1 degree C. So to use this model, you know the initial temperature of your solution. I'll round this to 23 degrees Celsius. And that means that I can put the right number of joules to say, yeah, this water gram started at 23 degrees Celsius, so did its neighbor. If each gram of water started at 23 degrees C, these are the joules that are in the water molecules as kinetic energy, heat. Here's the IC 2020 model of the reaction between the HCl and sodium bicarbonate, baking soda. I'm now dragging out an HCl molecule. Keep an eye on this number here, kinetic energy converted to potential energy. When a reaction occurs, 4 joules of kinetic energy gets converted to potential. Those joules of kinetic energy come out of the water molecules. So as you see, the water molecules get slower. They change color as they're losing kinetic energy. So each reaction that occurs takes away 4 joules. That's 1 small bead. If one reaction occurred, that gram of water gets a little bit colder. If another reaction occurs, that gram of water gets a little bit colder. To get the temperature to be 0 degrees Celsius, you need to take away all the joules, all the beads.